Let's add and subtract some fractions and rational expressions with unlike denominators. Let's take a look at a fraction first. Least common denominator here is equal to 30. Right, that is the lowest number that both 10 and 15 can multiply to. 10 times 3 and 15 times 2. 21 over 30 plus 8 over 30 is equal to 29 over 30. Now we can rewrite the number 10 as 2 times 5. We can rewrite the number 15 as 3 times 5. This is factoring. So if we take these unique factors, right, we don't need to use this 5 because we already have 1 over here. But 2 times 3 times 5 is equal to 6 times 5, which is equal to 30, and this is our LCD. So in order to find an LCD, you are doing what's called factorization and taking each of the unique factors that you see. Right, and in case that there is a factor raised to the second power, for instance, here, that means we would use that many factors there. Right, so we're not multiplying all of these numbers together. We're kind of eliminating the duplicates when we multiply. Right, this is one way to find least common denominator. As far as rational expressions go, most of the time, you're just going to be multiplying one denominator versus another. But take care of the duplicates because they will, we don't need the duplicates, and they will make your problem more complicated if they're there. So the only thing you're allowed to do to make the denominators the same is multiplication. Right? That's what we did up here. We multiplied 3 on the top and bottom over here, 2 on the top and bottom on the second fraction. For instance, if you're adding together 1x plus 2x, 1 over 2 plus 1 over x, your least common denominator is going to be 2x, which is simply just 2 times x multiplied together, 2 and x. Right, so one of the most common mistakes with an example like this, 1 over x plus 1 over x plus 2, is saying that you can add 2 to top and bottom of the first fraction to make them the same. This is not true. You are not allowed to add on top and bottom to make fractions the same. You're only allowed to multiply. Remember, when we were reducing rational expressions, I mentioned that x and x plus 2 are kind of treated as unique, different factors. And they're treated the same as far as LCD purposes go. The least common denominator here is going to be x times x plus 2. So in a case where there are 2 x's, like here, that means your least common denominator is going to have 2 x's in it. And because this problem, this denominator here has 2 2's, 2 times 2, that means our LCD is going to have 2 of those 2's. So that means our LCD for 1 over 2x squared plus 1 over 4x is equal to 4x squared. That's our LCD. So let's look at number 2 over here, 3 over 11x minus 5 over 3x squared. Our LCD is going to be 11 times x times 3. Again, those are these each unique factors here. And also times another x because this is x squared. Put it all together to get 33x squared. So 3 over 11x times 3x minus 5 over 3x squared times 11. And this is what's going to get us our common denominator of 33x squared. Up top, on the first fraction, 3 times 3x is 9x. On the second fraction, 55 over 33x squared. Now remember, you were multiplying the top and bottom by the same thing, whatever is you're choosing to get a common denominator. And what you choose to multiply is always dictated by the denominator. Numerator just follows suit. And we have to follow all the rules of multiplication, which is that you can multiply an integer with an algebraic expression. You multiply the coefficients. 3 times 3 is 9. And then x is just x. And when we are adding these together, because they do have a common denominator now, in this case subtraction, 9x minus 55 is equal to 9x minus 55. All right? There is no further way that you can simplify that. And this does not simplify. Again, this minus sign out here prevents any simplification, just like we learned a couple lessons ago. So this is your final answer. So when binomials are involved, I wouldn't say it's a little bit trickier. It could be, because again, we're trying to find the least common denominator first. So 4x minus 4, the numerator can stay put. You do not need to simplify or factor the numerator at this stage. So leave that alone. And x plus 2 as a denominator kind of gets left alone, but this 3x plus 6 can be factored. So you always have to factor the denominators when trying to find an LCD. And that's because, once again, we want to look for these unique factors so that we can multiply them together. Right? So our LCD is going to be 3 times x plus 2. And since we already have an x plus 2, then the other one here kind of is not needed. Leave your answer in factored form. I will explain why in a little bit, but this is our least common denominator. So without having to rewrite the entire problem, that means the second fraction needs to get multiplied by 3, and the first fraction stays put because the denominator already matches. So this becomes 4x minus 4 over 3 times x plus 2 minus 3 times x minus 2 over 3 times x plus 2. Right, notice that we are not doing any of the multiplication. We're just writing it down. And this is the safest way to do these problems, which is to save your multiplication until later. Now, once these denominators are the same, this becomes a problem like we did before. 4x minus 4 minus 3 times x minus 2. You write down one numerator plus or minus the other one. And that is over 3 times x plus 2. Again, notice that the denominator we are leaving as is. We are not distributing that 3. So we could distribute this negative 3, 4x minus 4 minus 3x plus 6. Three over x plus 2 right now is our same denominator. And this is equal to, we could combine like terms, like 4x and negative 3x, negative 4 and positive 6. This is going to equal x plus 2 up top, and then 3 over x plus 2 on the bottom. So now we could, hopefully it's pretty evident, based on our lesson on reducing rational expressions, that you can see that x plus 2, those binomials are going to cancel out. Now let's imagine for a moment that we didn't have 3 times x plus 2, but instead we distributed this 3 and had 3x plus 6. Well, what's going to cancel out now? That is nothing. Because again, you can only cancel out this, with the presence of this plus sign, the only thing you can cancel out is the entire x plus 2. And I don't see an x plus 2 down here. That means nothing is going to cancel. So in unfactored form, nothing is going to cancel. But in factored form, this does cancel. And that means our answer is 1 over 3, because this 3 is in the denominator, which means it's going to stay in the denominator. And up top, x plus 2 divided by x plus 2 is equal to 1. So make sure that you are leaving your denominator as factored, like this. Because if you decide to distribute this 3, what you're going to need to do later on is factor out that 3. Moving on. We can factor the denominator here to get 4 times a minus 7. And that means that our LCD is equal to 4 times a minus 7. So we get 5a minus 23 over 4 times a minus 7. And what we're doing here is multiplying the second fraction by 4. So that's minus 4 times a minus 4 divided by 4 times a minus 7. Now I've seen some students take a look at this and say, great, I can see that we can cancel 4. And then this is going to equal 5a minus 23 over 4 times a minus 7 minus a minus 4 over a minus 7. All right, take a look at what we have here. It's the exact same thing that we started with. Don't cancel out these 4's. We added this 4's in. Remember, we did it right there. The whole point of putting the 4's in is so that these denominators are the same. 5a minus 23 minus 4 times a minus 4 divided by 4 times a minus 7. Right? The whole point of putting the 4's in here is so that the denominators are the same, and now we can combine them. This is equal to 5a minus 23 minus 4a plus 16. This comes from distributing this negative 4. And our single denominator of 4 times a minus 7 carries through. Like terms, 5a minus 4a is equal to a. Negative 23 plus 16 is equal to negative 7. So this is going to work out the same as the previous problem. A minus 7's are going to cancel out. Our answer is 1 over 4. So the next problem illustrates something, which is that we can decide on an LCD of y minus 5 times 5 minus y, because these things, they look similar, but they're not the same, which means that they're unique. So then our LCD is just comprised of those two unique factors multiplied together. But in reality, actually, there is a faster way to do something like this. Because our goal is to turn the denominators, our goal is to turn the denominators to be the same. A minus b, for instance, times -1 is equal to -a plus b. This is a distribution of this -1, and it basically flips the sign of these two terms in here. And -a plus b can be rewritten as b minus a with the positive value first. So notice that we took an a minus b and turned it into a b minus a. So if our denominator, one of them says, in this case, y minus 5, and the other one is a reverse of that, 5 minus y. These are not conjugates. Remember, conjugates have the same terms with opposite signs. This is just a reverse order of subtraction. That means, for instance, we can take this second fraction and multiply everything by -1, right? And what's going to happen here? Right, this is going to become y minus 2 divided by y minus 5. I could do that better. Minus -y plus 2. That -1 is in front of there. And also let's take that a little bit slower. -5 minus y, right? So we're essentially putting a negative on top and bottom here. So y minus 2 over y minus 5 minus, that's going to be -y minus 2 because this negative sign distributes. Let's use that in another color. And this minus sign distributes as well. But remember what we did here, by distributing this -1, it basically reversed the order of A and B. So distributing the minus sign on the bottom here, we'll turn this denominator into y minus 5. And now our denominators match. All right, this is a quick way to get the denominators to match when they come in this particular format. So this becomes y minus 2 minus -y minus 2 on the numerator and y minus 5 on the denominator, which equals y minus 2 plus y. That's distributing this and that, plus 2, and then y minus 5 on the denominator. Combine like terms. Y plus y is 2y. -2 plus 2 is 0. So 2y over y minus 5 is your final answer. One more, number 6, is going to have a denominator, x squared minus 81, of x minus 9 and x plus 9. So our LCD is going to be x minus 9 times x plus 9, right? We need both of these here, and we don't need this one because we already have an x minus 9. So let's rewrite this. X plus 7 over x minus 9 is going to have to get multiplied by x plus 9 plus negative 28x minus 36 divided by x minus 9 and x plus 9. Once again, leave your expression, your denominator, in factored form. So x plus 7 times x plus 9 minus negative 28x minus 36. Remember to put parentheses around that. And we have one single denominator of x minus 9, x plus 9, because again, they are the same. So on top, we need to combine like terms. We need to FOIL x plus 7, x plus 9. We need to distribute that negative sign. So here we go, x squared plus 16x plus 63 is the result of double distribution there, plus 28x plus 36 is the result of that distribution. Denominator is x minus 9, x plus 9. So we got some like terms to combine here. X squared does not have a like term, but 16x plus 28x can be combined. Oh, I messed up. I'm sorry. That was a mess up. There is no distribution here that's necessary because this was a plus sign. I'm sorry about that. So this is a plus sign, which means that this here are both minus signs. Ooh, I apologize. So x squared does not have a like term. 16x minus 28x is negative 12x. 63 minus 36 is equal to a plus 27. X minus 9, x plus 9 is still your denominator. Sorry about that mess up. X squared minus 12x plus 27. We have a rational expression now that can be reduced, and the first step in reducing a rational expression is to make sure that everything is factored. X minus 9, x minus 3, because negative 9 times negative 3 is plus 27. Negative 9 plus negative 3, or negative 9 minus 3, is equal to negative 12. So x minus 9, x plus 9 is our denominator. Binomials of x minus 9 both cancel out. And our answer at the end is x minus 3 over x plus 9. Does anything reduce? No, it does not. Why? Because of this minus sign and because of this plus sign. And there we have it. Adding and subtracting rational expressions without a common denominator to begin with means that you have to force it to happen by finding a least common denominator and then by multiplying top